Hello everyone, in this video I'll explain how to solve one-step equations. Before we start, I have to remind you of what's a term. A term is a number or a variable, or it's the product or the quotient of a number and a variable. Example of a term that is only a number is like 3. An example of a term that is only a variable like x. An example of a product of a number and a variable is 3x, because we know 3x is 3 times x. Example of a term that is a quotient of a number and a variable like 3 over x, which means 3 divided by x. Terms are usually separated by addition sign or by subtraction sign, like 3a minus 2 over 5b plus 7x minus 4z plus 52. This is called an algebraic expression. Here the constants, or the constants in general, are the terms that is only a number. In this expression, like the 52. For the coefficients, they are the number in front of the variable in the term. 3a, the coefficient is 3. Negative 2 over 5b, the coefficient is negative 2 over 5. 7x, the coefficient is 7. And negative 4z, the coefficient is negative 4. Then, equations and how to solve a one-step equation. A one-step equation basically means you only have to perform one mathematical operation. It would be either addition, subtraction, multiplication, or division. So before we start learning the 4 types of operations in solving an equation, you have to know that this is called an equation. An equation, the difference between an equation and an expression. T plus 7 is an expression. 21 is an expression. When you get that t plus 7 equals and you get an equal sign equals to 21, so an expression is equal to an expression, this is called an equation. Now, in an equation, there are two sides. That's the first side with t plus 7, and the other side is the 21. You have to know that if you do anything to any of the side, it has to be done to the other side. So if I add 7 here, I must add 7 here. If I multiply 2 here, I have to multiply 2 here. So now, in order to solve an addition equation, basically, I have to keep this t, I have to make this t alone on that side so I know t equals what, because the target is to know the variable, which is t equals what. Here, there is plus 7 next to it, and I need to get rid of that plus 7. So in order to get rid of a 7, the only way is to subtract 7 from it. So because 7 minus 7 is going to be 0. So the t would be alone in that case. If I subtract 7 from that side, so I have to subtract 7 from the other side. And in other words, I just move the positive 7, which is next to the t, to the other side with the inverse operation, which is minus 7. In both cases, we would reach the same answer, which is that t equals 14. If we get back and check if 14 plus 7 would give us 21, yes, it's correct. Then a subtraction equation. If it's g minus 6 equals 40, then either one of two cases. I need to get rid of the negative 6, so I would add to this side of the equation positive 6, because positive 6, negative 6 will be cancelled together, and the g would be alone on that side of the equation. If I add positive 6 here, I have to add positive 6 here, so 40 plus 6 now is 46. A different method is that if the negative 6 is here, I take it to the other side with the inverse operation, which is plus 6, so it will be 40 plus 6, 46. Then, a multiplication equation, exactly the same. If it's 8n equal 32, then I'm taking the 8, it's 8 multiplied by n. I'm taking it to the other side with division, which is the inverse operation of multiplication, so it will be 32 divided by 8. Or I'm dividing this 8 by 8 to make the n alone, so I have to divide the other 32 by 8, so now n equals 4. Last type of operations is division. So if it's k over 9, k divided by 9 equals 11. So in order to make the k alone here, I'm taking that 9 to the other side with multiplication, so it will be 11 times 9, 99. Now, you just have to be careful if the order of the terms is not the same. I have to remind you that in addition and multiplication expression, the order of terms is not making any difference. You know that 4 plus 3 is the same as 3 plus 4, and that 3 times 4 equals 4 times 3. However, in subtraction and division, this is not the case, because 4 minus 3 is not equal to 3 minus 4, and 10 over 2 is not equal to 2 over 10, so it differs. Same goes for the equations. If I have x divided by 4 equals 2, in that case we will apply what we just explained, and I'm taking the 4 to the other side with the inverse operation, so it will be 2 times 4 equals 8. If we get back to the equation and check what we have just done, yes, 8 divided by 4 is giving us 2, so that's correct. What if 4 divided by x equals 2? If I apply the same way and I take the 4 to the other side, actually the sign is not before the 4. The sign is before the x. So if I take the 4 to the other side, it will be 2 times 4 equals 8. So 4 divided by 8 equals 2. No, that's incorrect. So in such cases, when the x comes to the other side, it's better to just exchange this with that, the term with the variable, without changing, without using the inverse of operation. So it will be 4 divided by 2 equals x. And if we test that, 4 divided by what will give us 2? 4 divided by 2. Same goes for subtraction. X minus 4 equals 2. In this case, what times what minus 4 would give us 2? It's actually 6 minus 4 would give us 2. And if we use the method of taking this number to the other side with the inverse operation, so it will be x equals 2 plus 4. That would be correct. If we apply the same way here, where the x is in the second place and the sign is actually before it, it will give us an incorrect answer, because actually the sign of the 4 is positive. Okay, so here in this case, I'm just taking the x to the other side and I'm getting the 2 in that side without changing anything. So in that case, it will be here 4 minus what will give us 2? 4 minus x would give us 2. So the conclusion that in subtraction and division, when the variable we are required to know its value is placed after the operation in the second place, we exchange the variable with the term on the other side of the equation without using the inverse operation. Like here, 32 over x, x is coming in the second place equals 2. I just changed the x place with the 8 place. I exchanged places and I kept everything as is. So now 32 over 8 equals x. X equals what? 32 divided by 8 equals 4. 44 divided by x equals 11. I just exchanged the place of 11 and the x with each other. So 44 divided by 11 equals x. X equals 4 in that case. 24 minus x equals 20. That would be 24 minus 20 equals x. So in that case, x equals 4. Thank you so much.